Namaste student. In this video I am going to explain isotopes, isobars and a third atomic model, that is a Bohr's atomic model. Okay. In the previous video I explained discovery of electron, proton and neutron and then atomic models, that is a J.J. Thomson's atomic model, Rutherford's nuclear atomic model, and at the last I told that what is the reason for the failure of John Dalton's atomic model. It is what is the reason for the failure of Dalton's atomic model: discovery of isotopes and discovery of isobars. Okay. Now, what is the meaning of isotopes and isobars? Now, here is the definition. Atoms of the same element have same atomic number but different atomic mass number. Atoms of the same element have same atomic number but a different atomic mass number. This is a definition of isotopes. Okay. Now here you can see the example. Hydrogen. Now, what is atomic number of hydrogen? It is 1. Mass is also 1. Then it was discovered the few more isotopes of hydrogen, that is hydrogen 2, hydrogen 3. Okay, H2 1, H3 1. That means below it is written as 1. Okay, so that is a atomic number, and above it is written as 1, 2, 3. That is a atomic mass number. So here atoms of the same element, its mass number is different, mass is different. Okay, so after discovery of isotopes, what happened? Dalton's atomic model, it was no more valid. It was no more valid. Here also one more isotopes discovered, that is carbon isotopes. Now there are 3 isotopes of carbon: carbon 12, carbon 13 and carbon 14. Same thing, chlorine isotopes: chlorine 35, chlorine 37. Okay. Now in the hydrogen, the first isotope H11, that is called as a protium. H12, that is a deuterium. H13, that is a tritium. Okay. So H11, it has no neutron at all. It contains only electron and only proton. Okay. Now what is the definition of atomic number and atomic mass number? I will tell you later. Okay. So first understand the concept of isotopes. So what is the meaning of isotope? It is a same element, atoms of the same element. Okay. Writing same element is very important. Atoms of the same element have same atomic number but different atomic mass number. These are the examples. This is very important concept. Now isobars. What is the meaning of isobars? Atoms of the different element, have same atomic mass number, but a different atomic number. See the example: carbon and nitrogen, atoms of the same, atoms of the different element. Carbon is different, nitrogen is different. So atoms of the different element. See which one is remains the same. 14 and 14. What is a 14? 14, it is nothing but a mass number. Atomic mass number remains the same, but which one differ? Atomic number is differ. 6 and 7. Atomic number of carbon is 6. Atomic number 7, nitrogen is 7. Same way here one more isobars: argon, potassium and calcium. Mass of argon, potassium, calcium is 40. But atomic number is argon is 18, potassium is 19, calcium is 20. So these are called as isobars. So what John Dalton, according to John Dalton, what he told: atoms of the same element having same size and same mass. But here what happened? Mass number is varies. So mass is also differ. Okay. And second postulates, what he told: atoms of the different element, the properties, differ in the properties such as mass and size. Here what happened, atoms of the different element but mass number remains the same. Okay, mass number remains same. Okay, so discovery of isotopes and isobars disprove the John Dalton atomic theory or model. Okay, so these two questions are very important. Define isotopes or what are isotopes, give an example. Define isobars, give an example. Okay, so hydrogen, if you want to write hydrogen as example, full 3 set you should write. You have to show the 3 different isotopes as 1, 2, 3. And carbon, if you want to write carbon as isotope, you have to write carbon 12, carbon 13 and carbon 14. Entire 3 you have to write. Okay, and isobars, same thing isobar. If example is asked, then carbon 14, nitrogen 14, both you should write. Okay, don't write only one as carbon 14 and 6. Okay, both you should write carbon, nitrogen 14, 14. You have to show the different element having a same atomic mass number. Now, as I told that it is a same atomic number, same mass number. What is the meaning of atomic number? What is the definition of atomic number? Atomic number means it is nothing but a number of protons. Now, usually protons, where it is present? Protons present in the nucleus. Protons and neutrons present in the nucleus. Electrons are present outside the nucleus. Electrons usually always revolves around the nucleus. So nucleus contains 2 particles, 2 fundamental particles, protons and neutrons. Protons and neutrons. Electrons present outside the nucleus. This you should keep it in your mind. Protons are positively charged particle. Neutron has no charge. Neutron has no charge. It is a neutral particle. Electron has a negatively charged particle. It is present outside the nucleus. Outside the nucleus, or I can call it as a shell or a orbit. In the later class I will explain what is the meaning of orbit or a shell. Okay, now what is the meaning of atomic number? Atomic number means it is nothing but a number of protons. Number of protons present in the nucleus. Number of protons present in the nucleus of an atom. Okay, or since atom is electrically neutral, okay, since atom is electrically neutral, it is also equal to number of electrons. It is also equal to number of electrons. Atom ಅಲ್ಲಿ ಎಷ್ಟು ಪ್ರೋಟಾನ್ ಇರ್ತದೆ ಅಷ್ಟೇ ಎಲೆಕ್ಟ್ರಾನ್ ಕೂಡ ಇರ್ತದೆ. ಆಗೇನಾಗ್ತದೆ, ಪ್ಲಸ್ ಮತ್ತು ಮೈನಸ್ ಚಾರ್ಜ್ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ ಆ್ಯಂಡ್ ಇಟ್ ರಿಮೇನ್ಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ನ್ಯೂಟ್ರಲ್. ಆಟಮ್ ರಿಮೇನ್ಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲಿ ನ್ಯೂಟ್ರಲ್. ಓಕೆ, ಸೊ atomic number means it is nothing but a number of protons present in the nucleus. Okay, it is also defined as it is nothing but a number of electrons present in the shell of a neutral atom. Why it is also related to number of electrons? Because since atom is electrically neutral, it is also equated to or considered that it is also equal to number of electrons. So keep it in your mind. What is the definition of atomic number? It is nothing but a number of protons. Now, how it is represented? It is denoted by symbol Z, letter Z. Okay, so for example, number of proton in hydrogen is 1. Number of electron in hydrogen is also 1. So what is atomic number of hydrogen is 1. Same thing, lithium has atomic number 3. That means number of proton is 3 and the number of electron is also 3. And helium, atomic number of helium is 2. That means the number of electron is 2 as well as number of proton is also 2. Okay, that you have to keep it in your mind. And according to the NCERT syllabus, you should know the element symbol along with the atomic number till 30 atomic number you should know. Okay, you should buy it till atomic number 30 with the symbol, with the element. Now What is the next one? Atomic mass number, or I can call it as a mass number, just mass number. It is nothing but a total number of protons and neutrons. Both are present in where? In the nucleus. Nucleus is present in the center of an atom. Nucleus is present in the center of an atom. Okay. So total number of protons and neutrons present in the nucleus, that is called as a mass number. That is called as a mass number. Actually, nucleus gives the heaviness to atom. Nucleus gives the heaviness to atom. That means mass is concentrated at the nucleus. Atomic mass is concentrated at the nucleus. Okay. So what is a mass number? Mass number definition is, it is nothing but a total number of protons and neutrons present in the nucleus of an atom of an element. Now how it is represented? Represented by symbol letter A. So now next, how it is related? Number of protons, neutrons and mass number. How these terms are related to each other. Now it is given a relationship as a Z plus N is equal to A. What is the meaning of A? A is nothing but a mass number. What is the definition of mass number? Mass number means it is a total number of proton and neutron. Total means it is a symbol of plus sign. Total means it is a symbol of plus sign, or sum of number of protons and neutrons. Protons means it is nothing but a atomic number. Protons means it is nothing but a atomic number. So that's why it is written as a Z. So number of neutrons, it is written as a N. So Z plus N, sum of a proton and neutron gives which one? Mass number, that is equal to A. I hope you understood the concept of atomic number and mass number, and how these three terms are related to each other. So I will repeat it again. Atomic number means it is nothing but a number of protons. Where it is present? Protons present in the center of the nucleus, center of the nucleus of an atom. Okay, it is also equal to, it is also equated to or equal to number of electrons. Why it is also considered as a number of electrons? Atomic number is also equal to number of electrons. Why it is considered? Because atom is electrically neutral. Because atom is electrically neutral, that's why it is also equal to number of electrons. Okay, what is a mass number? Mass number, it is nothing but a total number of total number of protons and neutrons. Protons and neutrons both are present in the nucleus. Okay, so based on this concept, how these three terms are related, that is number of protons, neutrons and mass number. Mass number means A, that is equal to sum means positive symbol, sum of which one? Number of protons. Number of protons means it is nothing but a atomic number, so that's why it is written as Z, and number of neutrons, that is a capital letter N. Okay, now so here explanation of equation is given, relation is given. Z means it is nothing but a number of protons, that is a atomic number. N means it is nothing but a number of neutrons in the nucleus. A means mass number. Now for example, a chlorine atom contains 17 proton and 18 neutron. 17 proton and 18 neutron. Calculate mass number. Calculate a mass number. So how it is calculated mass number? Mass number is equal to Z plus N. Formula Z plus N. So Z, how much Z? Number of proton. That means atomic number. 17 plus N. N means the number of neutron, that is 18. So 17 plus 18 is equal to 35. So one more problem it is given. Calculate the number of neutrons present in this. U means it is nothing but a uranium. Now upper part 235. It is written as a mass number. Upper part always mass number is written. Okay, and below 92, that is a atomic number. So mass number is 235, atomic number is 92. So how it is calculated? What is the formula? You have to apply A is equal to Z plus N. With the help of this formula, you can calculate number of neutrons. So I hope you understood the concept. Now, generally atom can be represented as, how it is represented? See, X, A, Z. X means it is nothing but a general symbol for an element or atom. General symbol for an atom or element. Okay. A means it is nothing but a mass number. It is always written as a upper part. Remember, mass number is written as in a upper part. Okay. As a superscript, and Z atomic number is written as a subscript or a below. Okay, so example is given. Write carbon atom symbolically having atomic number 6 and mass number 12. So how you should write? That is carbon 12 and 6. Okay, 12 is a mass number, 6 is a atomic number, and carbon symbol is a C. Now third model. So first model I explained. What is the first model? J.J. Thomson's atomic model. What he told in that it is a positive spheres. Atom is a positive spheres. Electrons are embedded in that. Okay, so his model is compared to J.J. Thomson's atomic model is compared to watermelon. Okay, watermelon or a plum pudding. And the second model is Rutherford's nuclear model. Rutherford's nuclear model. What he told, according to his point of view, atom has a two part. One is it contains a central nucleus part and outside the nucleus part. Nucleus is very heavy and volume of the nucleus, okay, or the space covered by nucleus is very small compared to the space of atom. And his model is compared to which one? Solar system. That means in solar system, planets revolves around the sun as it is. The same way electrons here also, in according to his point of view, electrons revolves around the nucleus. Electrons revolves around the nucleus. Okay, now third model, that is very important topic, Bohr's atomic model. Usually, this question is compulsory for the exam. Usually it is asked for 3 marks. 3 points you should write compulsory. Okay, so there are 4 points. First one, according to his point of view, what he told. Now, before explaining the postulates, I will show his photo. So this is a Neil Bohr. Okay. Now, what is a postulation? This is very important questions, compulsory question for the exam. Electrons revolves around a nucleus only in a fixed circular orbit. Only in a fixed circular orbit with a fixed energy and a fixed velocity. Rutherford, what he told? He also told that electrons revolves around the nucleus. Okay. But he not told that it is in a fixed circular orbit. He told just as in it is a circularly it will revolve. He told that electrons revolves circularly around the nucleus. But Bohr told that electrons revolves around the nucleus in a fixed circular path. In a fixed circular path. That path is called as a orbit or a shell. Okay, now he introduced orbit or shell concept. Bohr introduced the concept of orbit and shell. Okay, Rutherford, he just told that nucleus is present electrons present outside the nucleus. Okay, that nucleus revolves, that electrons revolves around the nucleus in a circular form. Okay, but Bohr told that electrons revolves around the nucleus but in a fixed circular path. This path is called as orbit or a shell, and this orbit or shell has a fixed energy. It has a fixed energy, and electrons also move. Since it is revolving, that means movement is there, so it move with the fixed velocity. It move with the fixed velocity. These orbits are also known as stationary states, because these orbits, it defines with the energy. It defines with the energy. So that's why it is called as a stationary states. That means I can explain this way. That is, suppose one example I will give you. I have a class. Okay, imagine the concept. I have a class, and then I kept seats. Seats are available in the classroom. Okay, it is a single seat. Okay, so many single seats or chairs were kept in the classroom, and on the chair I have written. Okay, the person those person who have to sit, that is the person who scored 90 marks. Person who scored 90 marks should sit first chair, okay, first chair. And then a person who scored 80 marks should sit in the second chair. Person who scored 50 marks should sit in the next, that is a third chair. That means so here I apply the condition, okay, here I apply the condition. Only those student can sit, occupy the first seat, who are those, that is those student who scored 90 marks, okay. That means only 90 marks student can sit in that chair, okay. So here also this is a fixed energy level, means energy of the shell is fixed, energy of the shell is fixed. So that's why it is called as these shell or orbits are called as stationary states, okay. So these shells are named as K shell, L shell, M shell, etc. Now, as long as an electron, second postulate, as long as an electron revolves in the same shell, as long as an electron revolves in the same shell, it does not lose or gain energy. As long as an electron revolves in the same shell, it does not lose or gain energy. ಎಲ್ಲಿ ತನಕ ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದೇ ಶೆಲ್ಲಲ್ಲಿ, ಸೇಮ್ ಶೆಲ್ಲಲ್ಲಿ ತಿರುಗ್ತಾ ಇರ್ತದೋ ಅಲ್ಲಿ ತನಕ ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜಿಯನ್ನು ಕಳೆದುಕೊಳ್ಳೋದು ಕೂಡ ಇಲ್ಲ, ಗೇನ್ ಮಾಡೋದು ಕೂಡ ಇಲ್ಲ, okay. As long as an electron revolves in the same shell, it does not lose or gain energy. So when it will lose or when it will gain, when it will jump from one shell to another shell, then only it will either lose or gain energy, okay. So that means shell, it is compared to the energy level, shell or orbit is compared to the energy level. So the energy remains constant, okay. Shell closer to the nucleus have lesser energy, shell closer to the nucleus have lesser energy. As it move away from the nucleus, energy level of the shell increases. As it move away from the nucleus, energy level increases, okay. Now third postulates, quantization condition. Now here, around the nucleus, what is this condition? What is the meaning of this? Okay, around the nucleus only those cells are possible in which angular momentum of the electron is an integral multiple of h by 2 pi. h by 2 pi. Around the nucleus only those shells are possible in which the angular momentum of the electron is an integral multiple of h by 2 pi. Actually, this postulates itself, it is a limitation of Bohr's atomic model, okay, limitation or a drawback of Bohr's atomic model, because he could not explain why it is, why shell it is considered as a 1, 2, 3, why shell number is not considered as a 1.2 or 1.5, like that, okay. Always a shell number we considered as a whole number ratio. Around the nucleus only those shells are possible in which the angular momentum of the electron is an integral multiple. Integral multiple means it is a whole number, integral multiple of h by 2 pi, okay. So what is the meaning of angular momentum? Momentum, it is entirely pure physics word, okay. Here I will just explain what is the meaning of momentum after explaining the fourth postulates. After explaining the fourth postulates, I will explain what is the meaning of angular momentum. Now, what is the fourth point? Fourth point or fourth postulates, when electron jumps from an outer shell to inner shell, jumps from outer shell to inner shell, the energy difference is emitted in the form of photon, and electron jumps from inner shell to outer shell, the energy difference is absorbed in the form of a photon. Okay, this I will explain again in detail. Now, as I explained in the video, here I will explain once again Bohr's atomic model. What is the first postulates? Electrons revolves around the nucleus in a fixed orbit with a fixed energy and fixed velocity. What is the meaning of this? See, this is a nucleus. Okay, this is a nucleus and this is a orbit. Now electrons revolves around the nucleus in a fixed orbit. Now fixed orbit, what is the meaning of fixed orbit? That is in a with a certain distance, with a certain energy level, electrons will revolve around the nucleus. It is in a circular path. It is in a circular path. According to Bohr, electron revolves around the nucleus in a circular path. That circular path is called as an orbit or a shell. Orbit or a shell. Okay, so this is a orbit or a shell. Okay, this is a nucleus. This is a shell or a orbit. Electrons revolves around the nucleus in a fixed orbit with a fixed energy and a fixed velocity. Now here, why it is called as this shells are also known as a stationary level. Stationary level. Stationary energy level. What is the meaning of this stationary energy level? Now here, now these are shells considered as n. Okay, so this is n is equal to 1, n is equal to 2, n is equal to 3. If I draw one more circle around the nucleus, then this is a n is equal to 4. Like that it will go. Okay, so now as shell is closer to the nucleus, it has a lower energy. As a shell closer to the nucleus, this shell has a lower energy. As shells move or go away from the nucleus, okay, then that means outer shells having a higher energy, so n is equal to 1 compared to n is equal to 3. N is equal to 1 level has a lesser energy, n is equal to 3 has a higher energy. Okay, so this is in a fixed energy level. This is in a fixed energy level. That's why it is called as a stationary energy level. Okay, stationary energy level. Now these shells are also referred as K shell, L shell, M shell, N shell, etc. Okay, based on the energy level, each shells are classified, or it is also called as a K shell, L shell, M shell, N shell, etc. Okay, now I hope you understood the first point. So electrons revolves around the nucleus in a circular path. That path is called as orbit or shell, but this is in a fixed orbit or with a fixed energy. But in the case of Rutherford, what he told, electrons revolves in the nucleus. It is not in a fixed path. It is not in a fixed path. Circularly it revolves around the nucleus. Okay. Now second point. What is the second point? Now second point, this part I will erase. Okay. Now, as long as electrons remains in the same shell, electron neither lose energy nor gain energy. Okay, here suppose this is a nucleus. Now shell I will draw around the nucleus. Okay, imagine that this electron, as long as this electron revolves in this same shell, in this same shell, this electron will not neither lose energy or nor gain energy. Okay, when it jumps from this shell to this higher shell, it will either gain or lose energy. That I will explain as in the as a fourth point. Okay, so second point, what it says, as long as electrons remains in the same shell, this electron neither lose energy nor gain energy. So this is a explanation about second point. Now third point, what is the meaning of third point? That is quantization condition. Quantization condition. Actually this word is not there in the textbook. Okay, quantization condition. That means, what is the meaning of quantization? Quantization means here electron is quantized. Electron is quantized. That means available in a fixed amount. Available in a fixed amount. Available in a fixed amount. Quantized meaning available in a fixed amount. What is that fixed amount? Okay, now first I will explain the postulates. Around the nucleus, only those shells are possible. Around the nucleus, only those shells are possible whose angular momentum is integral multiple of h by 2 pi. Integral multiple of h by 2 pi. Actually, this is one of the limitations of Bohr's atomic model. Bohr could not explain why it is. He could not explain why integral multiple of h by 2 pi. Now, what is the meaning of this? Around the nucleus, only those shells are possible whose angular momentum is integral multiple of h by 2 pi. Now, here, nucleus, around the nucleus, electrons are revolving. Okay, so here, now, here I am saying that n is equal to 1. This is n is equal to 2. This is n is equal to 3. Okay, that means shells we are giving nothing but for the shells we are considering as a always whole number. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Like that it will go. Okay. We cannot say like this, n 1.5 or n is equal to 2.5 or n is equal to 3.2. This is not there. Okay, so it is always a whole number. N value, shell's number, it is considered as a whole number. Okay, so around the nucleus only those shells are possible whose angular momentum is integral multiple of h by 2 pi. Now h by 2 pi. Now here h means Planck's constant. Now here angular momentum. What is the meaning of angular momentum? I hope you understood the meaning. The meaning of entire statement is shells, it is written in the form of a whole number. n is equal to 1, n is equal to 2, n is equal to 3, like that it is written, not like n is equal to 1.5 or 2.5, 3.2, like that. We can't say the shell's value is 1.5, 2.5, like, okay. So this is the meaning. Now here, what is the meaning of angular momentum? I will explain angular momentum. Okay, now angular momentum. What is the meaning of angular momentum? Okay, now what is the meaning of momentum? This is a physics word. Mass with acceleration. Mass with acceleration or mass with the velocity. Okay, now here I will say the difference between these three words: velocity, speed, momentum. Okay, actually if we see, the meaning is almost the same: velocity, speed or momentum. But if you go deep to the topic, okay, there is a difference between velocity, speed or momentum. Now here I will give one example, as that is, what is the difference between velocity and momentum? Velocity and momentum. Okay, now if I take the example as imagine that I will give one example, that is, in one road loaded lorry, okay, in another road unloaded lorry on the on the road. Okay, now here, which will reach early, whether loaded lorry or unloaded? Okay, so of course you will say that is a unloaded, empty lorry will reach the point early. Okay, why? In the loaded one, mass is present, weight is present, so it affects the speed. But in the empty lorry, nothing is there in the empty lorry, so it will reach fast. Mass is not present. Okay, now this is one example. This is example for the momentum. That means mass with the velocity I am explaining. Mass with the velocity I am explaining. Now if I want to explain just velocity, okay, now if your target is, I will give a task to two driver. Okay, that is, I will tell one driver that is within a 15 minutes you have to reach the student to ST.SEBASTIAN college. For both the driver I will give a task. Okay, within a 15 minutes driver should reach the students to ST.SEBASTIAN PU college. Okay, now to come to our college, there are so many roads. Okay, one driver, he may take a long route to come. Another driver, he may take a shortcut route to come. Okay, but my intention is he has to reach within a 15 minutes. Okay, so here mass does not depend on the speed. Okay, understood? Okay, this is called as a velocity. So I hope you understood what is the meaning of a velocity and momentum. Momentum, whenever momentum word comes along with the speed, which will come mass. Along with the mass, we are counting the speed. We are calculating the speed, okay, or velocity. So this is about the momentum. Now what is the meaning of angular momentum? Now angular momentum, see, nucleus, okay, electron is revolving. Now electron, since it is a particle, it has a mass. Since it is a particle, it has a mass, and since it is a revolving, it has a velocity. It has a velocity. Okay. Now if I consider electron is a particle. Since it is a particle, it has a mass. Since it is revolving around the nucleus, it has a velocity. So electron both has mass and velocity. Now here electron revolves around the nucleus in a circular path. Whenever circle comes, what is there in a circle? What is the main property of circle? It has a radius. Okay. So electron is moving. Now in momentum there are two types, linear and angular momentum. Linear and angular momentum. Linear means moving in a straight line. Linear means moving in a straight line. Okay. But angular means it is in a circular path. That means, so angular momentum of electron, so I will come back to the postulates. Angular momentum of electron is integral multiple of h by 2 pi. So what is the angular momentum? What I told, momentum means it is nothing but a mass with the velocity. Okay. Now since it is angular, so angular means it is nothing but a circular path. So in a circle, what is the main property? Radius should be there. Okay. So mvr means it is nothing but the angular momentum. So this is equal to which one? H by 2 pi. Okay. Now in an atom, it contains many shells. It may contain many shells, 1, 2, 3 or 4. So these shells are considered as n number. N is equal to 1, n is equal to 2, n is equal to 3. So each shell has angular momentum. Okay. Electron is present in each and every shell. So electron present in the first shell. So angular momentum of that electron is mvr is equal to n by h by 2 pi. Okay, I will rewrite it again here. That means here nucleus, this is an electron, shell. So electrons are present in a different shell. So angular momentum, I told this is momentum. Angular means radius must be present. This is a radius since it is a circular way. Okay, this is a radius. Okay, so mvr means angular momentum of electron is integral multiple of h by 2 pi. Now if I consider for the first electron which is present in the first shell. So first shell means it is nothing but n is equal to 1. Okay, so this is a angular momentum of this electron is this much. That is mvr is equal to 1 into h by 2 pi. So if I want to calculate angular momentum of this electron, this is present in which shell? Second shell. So mvr is equal to 2 into h by 2 pi. Now if I want to write angular momentum for this electron is present in third shell. So angular momentum for this one is 3 h by 2 pi. If electron is present in the fourth shell, then it is 4 h by 2 pi. Okay, so these n number, it is in a whole number ratio. I can't write like this. mvr is equal to 1.5 h by 2 pi. I can't write. Okay, mvr is equal to 2.3 h by 2 pi. Okay, this is wrong. So this is explanation for a third point, that is around the nucleus only those shells are possible whose angular momentum of electron is integral multiple of h by 2 pi, integral multiple of h by 2 pi. I hope you understood the concept. Okay, now the last point, fourth point here. What is the second point told? As long as electron revolves in the same shell, as long as electrons revolves in the same shell, neither lose energy nor gain energy. Okay, ಎಲ್ಲಿ ತನಕ ಎಲೆಕ್ಟ್ರಾನ್ ಒಂದೇ ಶೆಲ್ ಅಲ್ಲಿ ತಿರುಗ್ತಾ ಇರ್ತದೋ ಅಲ್ಲಿ ತನಕ ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜಿಯನ್ನು ಕಳೆದುಕೊಳ್ಳೋದು ಕೂಡ ಇಲ್ಲ, ಪಡೆದುಕೊಳ್ಳೋದು ಸಹ ಇಲ್ಲ. ಓಕೆ, ನಾವು if suppose, now this I will suppose, if I write in this way, imagine that electron is present in a first shell. This is a shell. Okay, n is equal to 1. This is n is equal to 2. So here I will write like this, so it is easy to. Now suppose, imagine that electron is present in the first shell, this electron. So this electron, if start jumping from inner shell to outer shell, start jumping from inner shell to outer shell. Okay, usually when it will jump, imagine that if I heat the atom, okay, what happened? Electron, it takes energy from the heat. Electron, it takes energy from the heat. Okay, so what happened? Electrons start jumping from one level to another level. Start jumping from one level to another level. But okay, now here I will show. Electron start. If I heat the atom, okay, atom contains electron, thus it will absorb energy from the heat, and this electron will jump to the higher level, okay. But here in the higher level it is unstable. Okay, so what it will do, this electron, it will come back. Okay, that means by absorbing the energy, it will go up outer shell, and here it will unstable at higher level, at higher energy level. This electron is highly unstable. So what it will do, immediately it will come back. Okay, so while coming back, this electron will emit radiation. This emitter will emit radiations. So this is called as a emission. Okay, this is called as a emission. Now here, now I will repeat it again. So if I heat the atom, electron which is present in the atom, it will take energy from the heat. Okay, and then that means it will absorb energy from the heat, and it will jump into higher level. Okay, so during that time what happened? Absorption will take place. So jumping from lower to higher, absorption of energy takes place. Okay, energy takes place. Now jumping from higher to lower, what happened? This absorbed energy is emitted, okay, in the form of radiation. So this is called as a emission. I hope you understood. So fourth postulate, it says that when electron jump from inner level to outer level, or inner shell to outer shell, inner shell to outer shell, energy is absorbed. Energy is absorbed in the form of photon. In the form of photon. This is a packet of energy, bundle of energy. Okay. And when electron jumps from outer level or outer shell or higher shell to inner level or inner shell, energy is, what happened? Absorbed energy is emitted in the form of photon. Emitted in the form of photon. This is absorption and emission. Okay, absorption and emission is explained in the form of a spectrum. This I will explain in the next video. What is the meaning of spectrum? I will explain in the next video. Okay. So I hope you understood the concept of postulates of Bohr's atomic model. So I will repeat it again. Electrons revolves around the nucleus in a circular path. That path is called as a orbit or shell. Second point, as long as electrons revolves in the same shell, it will neither lose energy nor gain energy. Okay, so around the nucleus only those shells are possible whose angular momentum of electron is integral multiple of h by 2 pi. Okay, and then the last point is, when electron jump from inner level to outer level, energy is absorbed in the form of photon. And when electron jumps from outer level to inner level, energy is emitted in the form of a photon. Okay, I hope you understood the concept of Bohr's atomic model. This is very important for the sake of exam. So usually it is asked for 3 marks, 3 point compulsory you should write. Now, failure of Bohr's atomic model. What is the reason for the what are the drawback or limitations of Bohr's atomic model? Now here it is applicable only to hydrogen atom. He explained all this information with the help of hydrogen atom. He did the experiment only on hydrogen atom or uni-electron system. Uni-electron system means, now in hydrogen how many electron is present? Since atomic number is 1, hydrogen contains 1 electron as well as 1 proton. Okay. Now in the case of helium atomic number is 2. Now here helium plus is written. Plus means it is nothing but 1 electron is removed. Okay. Now here, so how many electron is remained after removing 1 electron from the 2 electron? Only 1 electron is remained. So that means this type of system contains 1 electron. Okay, he explained the atomic model with respect to atom which contains 1 electron, atoms which contains 1 electron. Okay, so this is applicable only to hydrogen atom or uni-electron system like helium plus lithium 2 plus, like that. Okay, then spectrum of multi-electron system could not be explained. That only he explained only spectrum word I will explain in the next video. Okay, now he explains the spectrum of only hydrogen atom or hydrogen like atoms. Hydrogen like atom means atom which contains 1 electron. Okay, so does not explain why the angular momentum of electron is an integral multiple. This is already I told. Then last one is the uncertainty principle goes against Bohr's theory. This I will explain in the later class. What is the meaning of uncertainty principle? Okay, who explained this? All this information I will give in my next video. Thank you.